As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So, hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called super-Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet. And it's unlike anything we've ever seen before. Meet WASP 103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter, it's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b, not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet. And it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next? TRES-2b, or not to be, is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first because it's closest to the star, is different in a most horrible way. 55 Cancri e is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side. And between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. That's a getaway spot. HD 189377b, well, I'm not going to say that again, is the only exoplanet in the orbit of its star. And at first glance, it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. Better duck. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular. It's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70, hey, I can say that one, is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. So pal, what's eating you? My mother. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. Hey, you ask. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very, very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. I thought I thaw that thumbworth. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium. Located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1,800 degrees, perpetually blown over with winds reaching 600 miles per hour. And that's winter. Well, actually, I don't know that. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. That'll test your mettle. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Vacation? Nah, let's keep looking. Karat XO 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core.
You're trudging up a steep sand dune, 1 foot in front of the other. Out of breath, exhausted. You've lost too much water, and your body is beginning to shut down. You know you can't go on for much longer. Finally, you reach the top of the dune, and there before you is what you didn't want to see. It's so horrible that it takes seconds to sink in. Stretching to the horizon is a literal sea of endless sand dunes. You're stranded, alone, lost, far from salvation on the planet Arrakis. There's really nothing more breathtaking than the fantastical worlds created in science fiction, from planets of ice to lush luminescent jungles. While this particular planet may only exist in literary and cinematic outer space, Arrakis is not a place you want to take your family to for a picnic. For those of you who haven't seen the 2021 movie Dune, don't worry, I won't spoil it for you. You may not have seen the 1984 version either, or the miniseries from 2000, several computer games, or read the 6 novels by its original creator, Frank Herbert. And yet, you know that much of the action in Dune takes place on the desert planet of Arrakis. No cute robots there, only harsh temperatures, and somewhere beneath the dunes, giant sandworms. And when I say giant, I mean massive. They can be up to 1,400 feet long, a third longer than the Earth's largest creature, the blue whale. Scientists wanted to know if people could survive on a planet of endless sand dunes. But before I talk about what they did, let's discover a little more about the planet itself. Arrakis is already populated by a people known as the Fremen. They are native to the planet and have adapted to survive its severe desert landscapes. They created a full-body outfit called a still suit. It's designed to preserve the body's natural moisture, such as sweating. It filters the impurities and circulates them back into catch pockets as drinkable water. Probably doesn't taste amazing, but it'll keep you alive. A still suit in good condition can allow the wearer to survive in the searing desert for weeks. If you or I were to be dropped on Arrakis, or indeed any desert environment, what would happen? It really depends on the temperature. Obviously, the hotter it is, the harsher the impact on your body. The first stage of dehydration is thirst. This occurs after you've lost 2% in body weight. you'll already begin to feel unwell. Water makes up 60 to 70% of the human body. In a hot environment, the body can lose up to 0.4 to 0.8 gallons of water per hour. You'll start to sweat less and your body temperature will rise. Your blood will become thicker and harder to maintain oxygen levels. Your heart rate will increase. You'll start to overheat like an old car, making you more tired and less able to function. By the time you've lost 4% of your body weight, fainting will occur. By 7%, organ failure begins. You get the picture. Pity that you didn't have a still suit. Thankfully, the movies don't physically transport us to such a place, so we can sit comfortably eating our popcorn and downing a large drink. I always get thirsty watching movies set in a desert. A group of British climate scientists must be passionate dune fans because they decided to explore this planet in their spare time for fun. They built an actual 3D digital climate model of Arrakis. First, they collected all the data on Arrakis they could find. They scoured the Dune fandom wiki, as well as the incredible Dune Encyclopedia, a book with thousands of cross-referenced entries that took 8 years to compile. What they learned is that the atmosphere of Arrakis is made up of nitrogen and oxygen, enough for human life to exist. A good start. The planet's surface is almost entirely dry deserts. Yet there are also mountain ranges that shelter the planet's limited indigenous life forms, such as the Fremen. The giant sandworms that inhabit the planet also contribute to the planet's unique ecosystem. Their internal workings are like that of a blast furnace. They produce intense heat and in turn supply oxygen to the almost plantless world. Just don't get in their way if they're out for a Sunday stroll. Located deep within the mountains of the planet are water reserves. There are also small amounts of water in the form of vapor in the atmosphere. This water is harvested via wind traps. The polar regions have a milder climate and are more hospitable to humans compared to the vast, desolate wastelands of sand dunes. Thanks to those regions, Arrakis's overall geography makes it a relatively habitable planet, in theory. To find out if the geography and environment of Arrakis was physically possible or merely a set of fictional ideas, the scientists had to turn to a climate model. Fortunately, such technology already exists. It's used to predict weather and other climate factors. The scientists told the climate model everything they knew about Arrakis, including the planet's orbit and what the atmosphere consisted of. It's similar to Earth, though with slightly less carbon dioxide. The biggest difference in atmosphere is that Arrakis has a much larger ozone concentration, 0.5% of its atmosphere, compared to just 600,000ths of our own. With all of this complex data, they needed a giant supercomputer to process it. Even then, it took an incredible 3 weeks to get the results, but it was worth the wait. What they discovered was that in the warmest months of Arrakis, the temperature reached around 113 degrees Fahrenheit in the tropics. In the coldest months, the weather didn't go below 59 degrees Fahrenheit, not too dissimilar to Earth. In spite of that, the most extreme temperatures would actually be in the mid-latitudes and also in the polar regions, while the summers would be as hot as 158 degrees Fahrenheit, which is aligned with the book. The winters would be just as extreme, going from negative 40 degrees Fahrenheit in the mid-latitudes to as low as negative 103 degrees Fahrenheit at the poles. That's even colder than Alaska. How is this possible? The model showed that the polar regions of Arrakis have a much higher atmospheric moisture and high cloud cover, which would increase the temperature, as water vapor is considered a greenhouse gas. The book also mentions that there are polar ice caps, certainly in the northern hemisphere. In spite of that, the model revealed that the summer temperatures would melt any polar ice. Further to that, there would be no snowfall to replace the ice caps in winter. So much for a snowy winter's vacation. Another disparity is that no rain falls on Arrakis. Again, the model says otherwise. It proved that there would be rain, although only in small amounts. The rain would occur in summer and fall. It would primarily be confined to mountains and plateaus. There would be cloud cover in the polar latitudes and tropics as well. The scientists then posed the question that everybody really wanted to know: can humans legitimately survive on Arrakis? Realistically, the tropics would be the most hospitable place for people to live. Even so, most people in the dune world live in the mid-latitudes, where the hottest temperatures occur. Not very smart. The average monthly temperatures would be 120 to 140 degrees Fahrenheit, and this would be lethal for humans, even with still suits. While the body would be kept cooler, in line with the outfit's design, the skin is still exposed to the sun and heat. Not only would you look like a lobster, you'd probably fry. Youch! Life outside of the tropics in winter would also be impossible without technology. The cities would suffer extreme conditions in both winter and summer, akin to intense locations on Earth, like Siberia, which has brutal winters. Not the best locations in which to build your cities. No one could find fault with Frank Herbert, though, who passed away in 1986. His first Dune novel was published in 1965, though he'd already begun thinking about it in the late 1950s. He had visited the Oregon dunes and became fascinated by the movement of the sand dunes. He realized that without some type of vegetation, or poverty grasses which the Department of Agriculture was trying to introduce, the sand could move incredible distances. And with such force, it could swallow whole highways, lakes, and even cities. All of this was years before a man called Syukuro Manabe published the world's first climate model in 1967. In 2021, Manabe shared the Nobel Prize in Physics, the same year he turned 90, for the modeling of Earth's climate and predicting global warming. What a legend! Taking all of this into account, Frank Herbert wasn't far off the mark when it came to his fascinating world of Arrakis. While not strictly scientifically accurate, Arrakis is a realistic planet and humans could indeed live there. Just make sure you apply a thick layer of sunscreen in the summer. Herbert's novel Dune has sold millions and is considered one of the most influential science fiction novels of all time. His son Brian, already an author, took up the Dune mantle in 1999. He, along with author Kevin J. Anderson, have written many more novels in the Dune universe. The fascinating legacy lives on. Next time you plan on visiting Arrakis, please don't go in the summer. And make sure to bring your still suit. Water's pretty expensive. Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called Tress 2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. Tress 2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of Tress 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes Tress 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light-years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets. But Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
TRES-2b is a planet where night never ends. And it's not your regular night with stars shining in the beautiful skies. Here it's pitch dark and scorching hot. TRES-2b is a gas giant, roughly 1.5 times more massive than Jupiter, and its surface absorbs light better than charcoal. It might also have a faint dark red glow because of its burning air, which is as hot as fresh lava. Lovely. In the star system of 55 Cancri, there are 5 planets, 4 of which are gas giants similar to Jupiter and Saturn. But the 5th one, or rather the first, because it's closest to the star, is different in a most horrible way. 55 Cancri E is so close to its sun that half the planet's surface is a literal ocean of molten lava. The other half is in eternal darkness because it never sees the sun. The planet is always turned to its star on one side, and between the scorching and the dark, there's the twilight zone, a thin strip of gloomy nothingness. HD 189377b, I'm not going to say that again, is the only exoplanet in the orbit of its star, and at first glance it looks quite pretty, blue and white swirls making up wondrous patterns on the surface. But these pleasant colors actually come from hard silicate particles in the planet's atmosphere, which means it rains glass here. But the worst is that winds reach the speed of 5,400 miles per hour, or almost Mach 7. Well, for comparison, the fastest wind speed on Earth was 254 miles per hour, over 20 times less. Thus, the glass falling from the sky travels horizontally at hypersonic speeds, shredding everything in its path. The next system, whose name I won't even try to pronounce, this one, has 3 exoplanets, which are all being slowly destroyed by their own star. It happens because that star is not a regular, it's a pulsar, a rapidly spinning core of an exploded star. It creates powerful electromagnetic pulses in several directions while rotating at several thousand times per second. As a result, the planets orbiting this deceased star are slowly being eaten away and will eventually disappear entirely. Kepler-70 is a hot blue dwarf star that exploded into a red giant some 18 million years ago. At the time, it was orbited by at least 2 planets, the closer of which was a Jupiter-like gas giant. Its name was Kepler-70b, and it still exists, but the overgrown star consumed it and transformed it into a blazing hot rocky world. Right now, it's one of the hottest planets ever discovered. Its temperature is higher than the surface of our Sun. It was lucky to survive spending time inside the star, but it's evaporating now and will probably be no more in the near future. WASP-12b is one of the weirdest and saddest planets out there. The enormous gravity of its star, combined with the planets consisting mostly of gas, result in the star slowly devouring its protege. WASP-12b has already taken the form of an egg, stretched toward its merciless sun, and it's unable to do anything with its condition. In another 10 million years, the planet will inevitably succumb to the voracious star's appetite. If you ever wondered what it's like to walk on ice and hot coals at the same time, Gliese 436b is a planet that would give you a vivid example. Being extremely close to its sun, the Neptune-sized exoplanet boasts temperatures hotter than a blazing oven, and yet it's covered in ice, which burns incessantly. This ice is much denser due to the enormous gravity of the planet, staying solid even under extreme conditions and not melting away. No list of frightening worlds could do without mentioning Venus, the Earth's evil twin. The second planet from the Sun has an atmosphere so thick and full of clouds that its surface is much hotter than that of Mercury. Volcanic eruptions constantly thrash Venus. Its gravity is almost 100 times stronger than ours, and those clouds I mentioned are not made of water but of sulfuric acid, which condenses and rains down on the ground, adding to the inferno. But even if you were brave, or crazy, enough to try to pass through these clouds, you probably couldn't. The winds up there are as strong as some of the most powerful hurricanes back on Earth. Here we have a very long name for a very cold planet. Although the host star is not too far away, it's a small and rather cool red dwarf, whose light and heat barely even reach the planet. The temperatures out there fall as low as minus 370 degrees, which is only marginally warmer than absolute zero. The exoplanet is thus dark, gloomy, and covered in eternal ice that never thaws. Still, if it has a rocky core, it might generate some heat, so there's a chance that deep below the frozen surface, some unknown alien things might lurk. Dimidium, located roughly 50 light-years away from our solar system, is a planet hostile to any living thing on many accounts. It's tidally locked to its sun, which means one of its sides is always facing the star, while the other is always turned away. The hot side is heated to over 1800 degrees, perpetually blown over with winds reaching 600 miles per hour. Despite Dimidium being a gas giant, it has a large amount of iron in it, which melts and evaporates in the atmosphere, creating clouds. And when those cool down, they fall on the surface in the infernal rain of molten iron. Oxygen is usually viewed as an element that might bring life to a planet, but this is definitely not the case for Osiris. Scientists were shocked to find oxygen on this planet, or rather around it, because it's 8 times closer to its star than Mercury is to the Sun. This extreme distance makes Osiris a living melting pot, where anything that could burn will. It's also responsible for a very short orbit of the planet around the star. A year on Osiris is just 3.5 days on Earth. To boot, the atmosphere of the planet is constantly blown and melted away by the heat from its sun. Karat Exo 3b is neither as hot nor as cold as some of the others on this list, but it's terrifying in its own more insidious way. It's a gas giant similar in size to Jupiter, yet 20 times denser. This makes this exoplanet's gravity weigh down on everything on its surface 50 times more than it would on Earth. Stepping on it would be your ultimate doom, because you'd be immediately crushed by the density of its atmosphere. Karat 7b is another oven-like world. Its day-to-day temperature is over 4,000 degrees. Combined with the rocky surface, it presents an infernal landscape. The rocks on the ground bubble and boil, evaporating in the atmosphere, where they cool down and eventually fall back on the surface in a brimstone rain. The saddest thing about Karat 7b is that it might have once been a gas giant whose atmosphere melted away from the heat, leaving only the scorched core. We're used to thinking that asteroids are the only free-floating rocks in space, but things like OTS-44 make you think twice and shiver. Imagine a planet about 11 times more massive than Jupiter roaming in space without being bound to the orbit of any star. Given its gargantuan size and mass, if OTS-44 collides with any other planet, it would utterly destroy it and go on floating as if nothing happened. Scarier still, scientists are sure there are millions of such rogue planets out there, just waiting to be discovered. There's no hard proof of their existence yet, But theoretically, carbon planets have formed somewhere closer to the center of our galaxy. Any oxygen getting in their atmosphere will get into a reaction with carbon and transform into CO2, forming black toxic clouds. On the ground, there would be oceans made of tar, spewing up geysers of methane and crude oil. There would be rains too, but they'd be far from refreshing. Torrents of pure gasoline and hot liquid asphalt would blast the ground and probably burst into flames on impact. Hard to imagine anything that would survive such conditions. So check this out. Astronomers have discovered an exoplanet they're calling Super Saturn. It's got rings over an AU wide. An AU is the astronomical unit, the distance between the Sun to the Earth. That's an incredibly huge ring system, hence its name. Super Saturn is being called Mamajek's object after the astronomer who led the team to whom we owe the discovery. Professor Eric Mamajek of Rochester University in New York found Super Saturn while scouring through data downloaded from wide-angle transit observations. WASP is the acronym for Wide Angle Search for Exoplanets. It's an ingenious project developed in the year 2000 by astronomers at Queen's University in Belfast, Northern Ireland, and St Andrews University in Scotland. Using 4 telescopes, the CCD video cameras on the scopes record the slight dimming of starlight caused by objects passing in front of stars. This is called the transit method of exoplanet detection. So, for example, the planet Venus transits across our view of the Sun every couple hundred years. A black dot, the silhouette of Venus, is visible, crossing in front of the Sun as Venus passes between our line of sight and the Sun. This tiny eclipse causes the amount of sunlight coming to Earth to be reduced by a minuscule amount, also known as teeny tiny. The same is true for all the stars in the Milky Way that have planets going around them. Exoplanetary transits in front of stars must be in direct line of sight with Earth for the starlight to be dim. Such transits do not occur very often. That's why thousands of stars must be looked at simultaneously for as long of a duration as possible, between 4 and 8 hours a night. WASP was created to stare continuously at as wide of a range of stars as possible. Maybe one of them would show an exoplanet transit. That translates into a lot of data being produced, about 40 gigabytes per viewing session. Computer scientists at Leicester University in England developed a computer program to store the data and generate photometric graphs of the light intensity of each star. Open University, also in England, joined the WASP project, took this data, and made it available for research by astronomers worldwide. The graphs of the intensity of starlight show that changes in its brightness are called light curves. These graphs have 2 axes. One is in the timeline axis, the other one is the intensity of light. As the object, considered an exoplanet, though it could also be a brown dwarf star, crosses in front of the star, the timeline axis keeps track of how swiftly it is moving. It tells us how close the object is to the star, while the brightness axis keeps track of how much the starlight dims. This way, we can find out how large the object is. Now, obviously, big objects will dim the light more and be easier to detect. At present, Earth-based equipment is not sensitive enough to measure the dimming caused by planets as small as Earth. Neptune's size and larger ones are the limit for WASP. However, the James Webb Space Telescope, which is now in operation, has a much greater sensitivity and will be able to resolve the transits of Earth-sized exoplanets. Now, I know you want me to get to Super Saturn, but there's something else you should be familiar with before we get there. If the exoplanet has an atmosphere, or, in the case of Super Saturn, a ring system, the starlight from the star the planet is transiting will shine through the atmosphere or ring system, and that can be detected too. The light curve will show less dimming in the photometric data, because not all the starlight is being blocked. Some light is still getting through the atmosphere or rings. This is important because it gives astronomers a reading of the atmosphere. The James Webb Space Telescope is fitted with spectroscopes that can determine the gas content of the transiting exoplanet atmospheres: oxygen, methane, carbon, etc. The WASP project has been really catching on. There's a Super WASP project now consisting of WASP North and a WASP South. One looks at the sky above the northern hemisphere, the other looks at the sky above the southern hemisphere. There's also a Next Generation Transit Survey, NGTS, based on the WASP project. It's automated, so astronomers don't have to stay up all night sipping coffee, but they can if they want to. Located at the European Southern Observatory in the Atacama Desert in Chile, the NGTS scans millions of stars and has discovered over 100 exoplanets, down to a size as small as 3 times the size of Earth. NGTS has started a Planet Hunters Club on social media. Citizen scientists can search the online database of light curves and perhaps discover your very own exoplanet. What had been a strictly British effort started by 1 or 2 astronomers is now a worldwide phenomenon. With the ability to read the spectroscopic signatures of atmospheric gases during exoplanet transits, a new idea emerged: techno-signatures. That is, specifically identifying gases in exoplanet atmospheres that are produced by civilizations. The James Webb Space Telescope can do this. Gases from pollution, such as chlorofluorocarbons (CFCs), can be seen spectroscopically if present. Tritium from fusion reactions, if they have them, can also be detected, along with heat patterns from cities on the planet's surfaces. Technosignatures is a recent concept that originated after the WASP project started. Who knows what it will turn up? Now let's get back to Super Saturn. The star that Super Saturn orbits is J1407, a small, dim, sun-like pre-main sequence star of the 13th magnitude. Huh? Well, the human eye can only see stars to about the 6th magnitude, and each magnitude is 2.5 times dimmer than the previous one. So it's not an exceptional star, just another telescopic star out there in the Scorpius Centaur region of the night sky. J1407 is a young star that hasn't yet settled into its stable, long-duration phase. This is important because Super Saturn, officially J1407b, is showing signs of having a ring system in an early stage of development. Super Saturn's light curve was tucked away in the mountain of data from the Super WASP project. Professor Eric Mamajek and his associate Matthew Kenworthy of Leicester University studied the data thoroughly and produced a detailed report on it. Knowledge depends on good data. The horizontal axis of J1407b's light curve, the time axis, is what's causing all the hubbub. It took Super Saturn weeks to transit across in front of its parent star, 56 days to be exact. Planetary ring systems that we are familiar with in our solar system orbit right around the equators of the gas giant planets and are very thin, from only a few meters thick down to a few centimeters. In a telescope, Saturn's rings will seem to disappear when the planet is at 0 inclination toward Earth. Saturn must be inclined at an angle in relation to Earth to see Saturn's beautiful ring system. It's something everyone should make a point of seeing: Saturn in a telescope. If Super Saturn's rings blocked most of the light from J1407 for 56 days, it means that the planet had to be orbiting at a steep inclination to its star. If it were at 0 inclination, we wouldn't see the rings blocking any light. Therefore, the orbital time could be determined, 10 years minimum to 200 years if the orbit is highly elliptical. The superplanet itself is calculated to be 24 times the mass of Jupiter, which means that if it is gaseous, it could be a brown dwarf star. Super Saturn appears to have a Mars-sized object orbiting around it, because there is a huge gap in the rings that was most probably cleared out by a large object. The Cassini division in the rings of Saturn is where the moon Mimas has cleared out a path through Saturn's rings. The light curve of Super Saturn has only been observed once. All the exoplanet detection systems are keeping an eye out for it to come back around J1407. No one knows when that will occur. Some astronomers have suggested that J1407b is a brown dwarf star system in itself, merely passing in front of, but not connected to, star J1407. An orbital reappearance of Super Saturn would disprove that conjecture. The center region of Super Saturn blocked out all the light from its primary star. This is what indicates that the ring system is new and in an early developmental phase. Over time, the very dense ring mass close to the planet is expected to thin as all this matter gets absorbed into the planet or ejected into space. This is what has happened with our solar system's gas giant planets. The Mamajek object is a shocker. Never before or since has a light curve been detected like Super Saturn's. Super Saturn has added a new chapter to our understanding of the formation of ring systems. So, here's to you, Super Saturn. Hope to see you again soon. While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways. So specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Badigan aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Badigan has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Badigan have found the perfect one. The Subaru telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigan's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there.
An exoplanet is any planet inside our solar system. Some of them are free-floating. Those are called rogue planets. They move around the galactic center. Others orbit their host star, or two. For the first time, astronomers discovered exoplanets in the 1990s. Since then, scientists have found thousands of them. And now, you can sneak a peek too. Spoiler alert, some exoplanets are pretty bizarre. Others resemble our home planet and could probably support life. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. This means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Another Earth-like planet, TOI 700d, is 100 light-years away from us in the constellation Dorado. It orbits a small and rather cool dwarf star that is about 40% of the mass and size of the Sun. Its surface temperature is half as high as that of our star. The outermost planet, which is the very TOI 700d, is almost the size of Earth. It also sits in the habitable zone of its parent star. No flares from TOI 700 reach the planet. This increases the chances of the exoplanet being habitable. This means it can potentially develop and maintain life. Scientists don't know for sure the exact conditions on the surface of the planet, but one of the computer simulations they've created shows a planet covered with an ocean. It has a very dense atmosphere dominated by carbon dioxide. Astronomers think a similar atmosphere surrounded Mars when it was a young planet. But another 3D model shows TOI 700d as an all-land, cloudless world. That's what our Earth would probably look like if it wasn't covered with oceans. Winds on TOI 700d move away from the night side of the planet and meet in the area that directly faces the star. There is an exoplanet that stands out among the rest because of its awesome magenta color. You can find this world in the Virgo constellation. The planet is called Gliese 504b. The distance between this planet and its parent star is 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists received proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers, It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptional strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. If you traveled 20,000 light years away from Earth, you'd come close to a red dwarf in the Sagittarius constellation. Such stars are very cool and small. Quite far away from this cold star, there's a planet. The distance between this world and its host star is so great that the planet receives very little heat. It's one of the coldest planets ever detected. The average surface temperature on the planet is lower than negative 360 degrees Fahrenheit. That's why the entire planet is covered with a thick layer of ice. If you stepped onto its surface, you'd see nothing but glaciers, plains, and mountains of ice. And still, astronomers claim life might exist deep beneath the frozen surface. All because the core of the planet is likely to generate enough heat to melt some of its inner ice. In this case, there would be an enormous subsurface ocean, maybe even swarming with bizarre life forms on the planet. One of the oldest exoplanets we know about is PCR B162026b. It's about 12.7 billion years old. It's almost 3 times as old as Earth, which appeared 4.5 billion years ago. This also means that the Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar, making almost 100 revolutions per second. Sunrises on this planet must look awesome. I bet the next exoplanet isn't like any other you might have seen before. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those of Saturn. The bizarre world is 434 light-years away from Earth. It's the only planet we know about that has rings similar to Saturn's. If you moved J1407b to our solar system and replaced Saturn with it, its rings would look many times larger than a full moon. Astronomers have noticed a gap halfway through the planet's rings. The chances are high that an exomoon the size of Mars orbits the planet somewhere within this gap. If you lived on this moon, you'd have an awesome view every time you looked up into the sky. This exoplanet, called WASP-12b, munches on the light coming from its star. It's one of the darkest worlds people know about. All because its day side consumes light rather than reflects it back into space. The planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. This is likely to be the main reason for the insane temperatures on the surface of the planet. They can rise up to 4,600 degrees Fahrenheit. It's almost half as hot as the surface of the Sun. WASP-12b travels so close to its host star that it needs just 1 day to complete one orbit. Its night side isn't as hot as the day side, a mere 2,200 degrees Fahrenheit. Because of this difference in temperature, water vapor and clouds gather above the surface of the planet. From time to time, swirls of material from the planet's superheated atmosphere spill onto its star. About 4,000 light-years away from Earth, there's an exoplanet that might be one enormous diamond. It's 5 times the size of our planet, but needs only 2 hours and 10 minutes to orbit its parent star. It's a pulsar rotating at a rate of 10,000 times a minute. The planet is denser than any other we've discovered so far. It consists mostly of carbon, which is so dense that astronomers think it might be crystalline. If it was true, it could mean that at least some part of the planet is diamond. On WASP-76b, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit smaller than Jupiter and located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between WASP 76b and its parent star is 10 times shorter than the distance between Mercury and the Sun. That's why the star and the huge planet are tidally locked. One side of WASP 76b always faces the star, and the other side is always pitch black. This bright blue exoplanet sits 62 years away from Earth. A bit larger than Jupiter, it looks calm and peaceful. Its blue color might remind you of our home planet. But this familiar appearance conceals the planet's horrifying nature. The beautiful hue comes from silicate atoms and particles that make up the atmosphere. But the wind speed on the planet can reach 5,400 miles per hour. That's 7 times the speed of sound. The temperature there can rise up to 1,600 degrees Fahrenheit. But this isn't the worst. In this bizarre world, it rains glass, sideways. So it's probably not the place where you'd like to spend your vacation.
It's the year 2600, and the New Frontiers program has finally begun. You've got the list of planets to plan dwellings for, and the first one is Venus. The Earth's evil twin sister meets you with a refreshing 800 degrees Fahrenheit and a beautiful sulfuric acid rainstorm. First of all, the heat means living on the surface here is next to impossible, so you immediately put the prospective house several dozen feet underground. The walls, floor, and ceiling must be made of some heat-resistant and durable material, so you make them out of hafnium carbide. Discovered way back in 2016, it withstands temperatures of over 7,000 degrees. Next, you install the air cooling and purification system. It captures the toxic air from the Venusian atmosphere and pulls it through a complex network of filters, delivering breathable air to the dwelling. As an added benefit, the temperature of this air can be easily turned up thanks to what's going on outside. You can create a separate room below the main space and dub it the generator room. The device there will use the almost infinite geothermal energy of the planet to provide the house with electricity. You think for a moment and add a geothermal bathroom as well. There's no water on Venus, but it can be extracted and separated from its acidic clouds. The piping system would include a heating unit for hot water and a cooling unit with liquid nitrogen for cold water. Another separate space is the garden. Since no plants can survive on the surface, you create a spacious hall with bright lights on the ceiling and a sprinkler system throughout the area. You have large patches of soil for vegetables, several acres for fruit plants, and a big patch in the center for a couple of long-living trees like oaks. They'll provide additional oxygen for the whole building. The garden is encased in a shell of hafnium carbide as well, so that the plants don't wilt in the excess heat of the Venusian soil. You check if everything's accounted for and go to your next stop. Saturn. It's a gas planet, but there's a thin yet stable layer that can be called the sweet spot. Its temperature is just right for humans to feel fine. You create a hover platform to build your house on. There's just no solid ground on Saturn at all. The platform's equipped with wind-powered turbines. The winds on the gas giant reach incredible speeds, so it will need to counteract them, at the same time feeding from the hurricanes. The pressure and temperature are just about right in this place, so your main concern is the wind again. You make the dwelling low and looking almost like a frisbee for better aerodynamics. The walls and roof are made from a single slab of sturdy metal, so that powerful gusts can't tear the roof away. You also make them several feet thick and add some windows with space-grade glass panes that won't break. Water can be extracted from another layer using a series of similar platforms with built-in pipes. Electricity and heat are no problem either, thanks to the powerful winds. The only problem here is food, but it can be imported from other inhabited planets at first, along with the fertile soil for the garden. You create a space for it on another hover platform for the future. Satisfied with your results, you head to the next destination on your list, Europa. This moon of Jupiter's is covered in a miles-thick crust of ice full of canyons and crevices. But deep below, there's a whole ocean of salt water bigger than all the oceans on old Earth taken together. You take it into account and go for an underground dwelling again. The temperature is freezing, but the closer you are to the hot planetary core, the warmer it is. You place the dwelling as deep as you can to safely extract water from the underground ocean. The walls and ceiling are padded with insulation, and in the cellar, there's a home water purification system that turns salty water into the potable kind. Since there's no atmosphere to speak of, the breathable air is extracted from the ice. As it melts, the water vapor is collected and filtered, then enriched with other necessary substances and delivered to the dwelling. As for food, you go for an unusual solution: edible marine plants and fish. You create a separate tank to cultivate algae right in the ocean, and different kinds of fish can be imported from old Earth and other inhabited planets to breed on Europa. Next stop? Pluto. The tiny dwarf planet, just 1/6 of old Earth in width, has a great potential for terraforming, so you immediately create a big dome for your dwelling. The sun shines much weaker here than in any other place in the solar system, so you make sunlight-enhancing panels all across the dome. They'll allow the surface underneath to receive more light and warmth, bringing the area to a comfortable temperature. The ice on Pluto consists of frozen water, just like on Earth, so you build a station for melting it and collecting the resulting liquid into large tanks for later use. There's also a possible liquid ocean deep under the surface, so you add a deep drilling platform, but put a question mark on it. You don't know if it's going to be useful yet. With the area warmed up and well lit, you make a pretty ordinary dwelling like ones we're used to on old Earth and terraformed Mars. A couple of stories, carbon or titanium alloyed walls and ceiling for durability, and a fortified cellar. Still, you also add emergency insulation padding that will only trigger if something happens to the lighting dome. If it's breached, the temperature will quickly drop to below freezing. There's also very little atmosphere on Pluto, so breathable air will have to be generated from the ice again. This time, you combine the water collecting system with the air generating facility. While one produces potable water, the other will collect vapor and enhance it with all the necessary elements. You even go as far as to create a weather controlling device. It will heat up or cool down different layers of the produced air and mix them together to create winds and rain clouds just like on old Earth. This will allow crops to grow in a more natural environment, and Pluto might even become a green planet one day. Right above, in the dark blue sky, Pluto's biggest moon, Charon, is hanging. It's half the dwarf planet in size, which makes it a spectacular view. Its climate is almost identical to that of Pluto's. In a fit of inspiration, you create a vacation home for Plutonians. Here, under a similar dome, they'll be able to explore another little world and look at their dwarf planet from the other side. Which is always the same side, by the way, like the Earth's moon, which reminds you of the next destination. Zarmina, previously known as Gliese 581g, is 41 light-years away, the longest trip so far. The planet's tidally locked to its sun, which means there's perpetual day on its one side and eternal night on the other. It's not only about light, but heat as well. The day side is much hotter, and the night side is partially covered in ice. Unless we terraform the planet, the most comfortable area to inhabit is right between the two sides, called the Terminator Zone. It's neither too hot nor too cold here, and there's an eternal twilight. The sun is always just above the horizon. The good news is that the atmosphere on Zarmina, although volatile, is rather close to the old Earth's, but you still cover the selected area with a protective dome just in case. Human dwellings here don't have to be specially protected from the elements, and there's liquid water too. You build a pretty generic house, much like the one on Pluto, but then add a few crucial details. First, the weather controlling device. Despite the old Earth-like atmosphere, dwellers will need a stable change of weather to grow crops. Then you cover the dome with moving plates. Living in a constant dust might be pretty depressing, so the plates will move in 12-hour patterns. During the daytime, they will turn to enhance the sunlight, while at night, they'll deflect it back, making the sky dark. After that, you travel to both edges of the Terminator Zone and install geothermal plants. On the hot side, the plant will generate energy for all the settlers' needs and take hot water to use in households. On the cold side, the system will make cold water from the ice. The night side can also be used as a giant refrigerator. Dwellers could store things they need frozen here. To make it easier to access, you stretch the dome from edge to edge and create some simple storage facilities where the night begins in earnest. Uh-oh. Something is nearing the surface of the planet. It looks like a fireball, hurtling closer and closer at a truly incredible speed. Soon, it becomes obvious that the collision is inevitable. Bam! The impact leaves a huge crater. It evaporates thousands of cubic miles of solid rock, and it also sets off a series of terrible natural disasters. Yeah, I know what you're thinking. You believe I'm talking about the catastrophic collision that occurred around 66 million years ago on Earth. You know, the one that's responsible for the extinction of non-avian dinosaurs and 3/4 of other life forms on our planet? But no, the disaster I'm talking about happened on a different planet. Scientists think that our close neighbor, Mars, once experienced the same catastrophe that struck Earth. It happened around 3.4 billion years ago. An asteroid collision might have caused a mega tsunami on the red planet, similar to the one that caused the Chicxulub impact on Earth. Scientists have identified an impact crater on Mars that was probably left by a comet or asteroid collision with the surface of the planet. Most likely, the space body landed in an ocean in the Martian northern lowlands, and the impact was so powerful that it caused a mega tsunami. Before the latest studies, the exact location of the impact crater wasn't verified. It was just a theory. To confirm it, a team of astronomers simulated a comet and asteroid collision in the area where they supposed the impact crater was. They even named this crater Hall. Hall is 68 miles across and lies in a region that is almost 400 feet below the supposed sea level. Anyway, the simulations formed several craters of the same size as Paul. One of the simulations claimed that these craters had been left by a 5-mile-wide asteroid that had encountered strong ground resistance. The other simulation showed that the craters had been caused by a bit smaller asteroid that met a weaker ground resistance. But according to both simulations, the impact crater was almost 70 miles in diameter, and the collisions produced mega tsunamis up to 900 miles away from the center of the impact site. The simulations also helped scientists estimate the height of the tsunami. It was about 820 feet tall, almost as tall as the Eiffel Tower. The authors of the study also suggest that the Pole crater might be similar to the Chicxulub impact crater on our planet. The Chicxulub asteroid, as we now know it, is believed to come from the outer reaches of the solar system. This space body was at least 6 miles across. It crashed into the shallow seawaters near the Yucatan Peninsula. This splashdown was so powerful that it left its signature on the entire face of the planet. In 2021, researchers found out that the collision had carved mega ripples into Earth's crust in the region of modern-day central Louisiana. An even newer study suggests that the asteroid also triggered a tsunami so devastating it eroded seafloor sediments half a world away. The team of scientists remodeled the events of the first 10 minutes after the impact, and the models showed that the asteroid had produced waves up to 30,000 times greater than one of the largest tsunamis people have ever recorded, the Indian Ocean tsunami that hit Indonesia in 2004. The collision displaced so much water that it created a wave almost a mile high. That's like 2 Burj Khalifas, which is the tallest construction in the world, stacked one on top of the other. And of course, all that empty space didn't stay empty for long. The ocean gushed back to fill the crater. But in the process, it only ricocheted off the crater's rim, which produced even more waves. After that, tsunami waves that were more than 33 feet tall traveled around the world at a speed of 3 feet per second, lashing at all coastlines on their way. Imagine a 3-story building rushing up to you. No wonder the largest and fastest-moving waves occurred near the impact area in the open waters of the Gulf of Mexico. Those rose more than 330 feet tall, which is taller than the Statue of Liberty, and moved at a speed 10 times greater than more distant tsunami waves. But back to the red planet. Some experts think that not 1 but 2 mega tsunamis could happen on Mars. They could be triggered by a pair of meteor impacts that were several millions of years apart. Between these two collisions, Mars went through a period of climate changes. As a result, liquid water on its surface turned into ice. In other words, the first asteroid impact most likely produced waves composed of liquid water, and the second tsunami was probably formed by rounded chunks of ice water. By the way, the largest asteroid to have ever crashed into Earth might not actually be the one that ended dinosaurs. A much more catastrophic collision likely happened about 3.5 billion years ago. New evidence scientists found in northwestern Australia suggests that the asteroid I'm talking about was 12 to 18 miles across. It struck Earth at an immense speed, releasing an unimaginable amount of energy. Now, this made me think, what if something like that happened these days? More than 30,000 objects that are circling Earth these days could potentially crash into our planet. NASA considers around 1,500 of them to be potentially hazardous. These space rocks are the remains left after the solar system was formed some 4.6 billion years ago. For example, in 2004, astronomers discovered a huge asteroid nearing Earth. The first observation showed that the chance of the space rock hitting our planet was less than 3%. The asteroid was named Apophis. It's more than 1,200 feet across and weighs about 20 million tons. It's supposed to streak across the sky on April 13, 2029. Apophis will pass at a distance of 19,000 miles away from Earth's surface. But even though this space rock might miss our planet in 2029, it doesn't mean it won't return 15 years later in 2036. If such an object hits our planet, the consequences will be unpredictable. They can vary from shattered glass and broken windows to most life forms getting wiped off the face of the Earth. And it'll probably affect the internet. Now that last thought is truly scary. But luckily, modern technologies are likely to help us avoid any catastrophic consequences. Experts have developed several ways to prevent a real-life disaster movie from happening. For one thing, we could use a spacecraft to knock this visitor from outer space off its course. Or it could somehow be blasted into pieces. Scientists could also slow the thing down with the help of concentrated sunlight. Or people could tug it away with a gravity tractor. That's a theoretical spacecraft that can influence objects in space without touching them. In sci-fi movies, a huge asteroid often sneaks up on Earth and turns out to be a nasty surprise to astronomers. It hurtles toward our planet at breakneck speed and gets discovered just weeks or even days before the collision. In reality, scientists are constantly watching all large objects in Earth's neighborhood. It means there would be plenty of time to do something before the inevitable happened. There are three kinds of missions scientists could prepare at short notice. Type 0, when a heavy spacecraft hurtles toward the intruder with one single goal, to knock it off its course. In this case, astronomers would have to rely on the already available information. The Type 1 mission would involve a scout. It would be launched first to get more close-up information about the space rock. Only after that, the main spacecraft would be launched. With more precise information, its journey would be way more productive. And if scientists chose the Type 2 mission, they would send a scout and a small spacecraft at the same time. The spacecraft would knock the asteroid a bit off its course. Then the scout would collect all the necessary information. Based on this data, the spacecraft would finish its job with a more fine-tuned second push. If none of these methods work, people could try going deep underground or even build a shelter on the ocean floor. But in this case, we'd need to find sources of energy that could help us survive for at least several decades. Plus, people would have to create a life support system that could somehow keep air and water fresh.
In a star system far, far away, to be more precise, 2,600 light-years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact, if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. Rogue planets produce only weak emissions, but not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called pillars of creation, an active star-forming region. Look, how cool is that? It's a clear night, and you're outside looking at the stars. The Milky Way alone seems overwhelmingly huge. You check on your phone and discover that the galaxy you're in at this exact moment is 100,000 light-years wide. For scale, 1 light-year is already a very long distance. For example, it takes 4.2 light-years to go from Earth to Proxima Centauri, which is the closest star to our planet other than the Sun. So, 100,000 light-years is way more than we normal humans can fathom. And that's just one galaxy. There's a whole lot more out there. Now, looking at this data, it seems pretty unlikely that we're the only life form out there, doesn't it? But how come we've never found anything else so far? Let's get one thing out of the way. Extraterrestrial life doesn't necessarily mean we're talking about little green people. It can also mean microorganisms, bacteria, and plants that can be found on other planets. The truth is, there's a big spectrum of possibilities for life on another planet. And taking into consideration that there are up to 50 billion planets in the Milky Way, it's very unlikely that we're alone in this big wide universe. And what does life on other planets look like? This is what we've spent years trying to figure out. Go ahead, think with me. A planet may be lifeless today, but it could have traces of organic matter or fossils, meaning that some life form was able to thrive there once. And it could also be that there are planets out there containing life with complex biochemistry, meaning they could have fauna just like we have on Earth, although probably not the same. NASA created a special science that is dedicated to studying life forms outside of Earth. It's called astrobiology. Ever since the space agency was created back in 1958, it didn't take long for it to start looking for extraterrestrial life. They quickly built an action plan. First, they needed to understand how life on Earth was formed, and secondly, how it could have formed on other planets. The first time NASA tried to look for life in outer space was in 1976. The Viking lander blasted into space, headed towards Mars. There were high expectations that humanity would find the first proof of extraterrestrial life. Unfortunately, the lander came back with images of a planet that looked barren and bleak, and scientists were extremely disappointed. Scientific conclusions on whether life could be detected over there were confusing. But hey, you need to know what you're looking for to find it, right? The failure of the Viking mission served to heat up debates amongst NASA scientists to define what life actually meant. And it also served to call their attention to a small but very important detail. Spacecrafts departing from Earth usually transport Earthling microorganisms and bacteria unintentionally, as they remain attached to the vehicle. It turned out that these bacteria could contaminate scientists' samples, so they needed to consider this. All of this made Mars expeditions take a back burner on NASA's short-term plans. There appeared a new priority-first question: what are the types and stages of life that space programs can hope to identify? Scientists might have encountered life on other planets, but they weren't able to identify it as life. That is why NASA began to study our own planet better. They studied everything, from ancient life forms that lived billions of years ago to living creatures that roam the planet today. They understood that the search needed to happen inwards as well as outwards. Let's take a look at the development of Earth's life from its inception. Imagine that this development can be represented as a ladder, or stairs, and each developmental stage is a flight of the bigger staircase. First, we would see basic chemistry, a soup of loose chemical elements like the ones we see in the periodic table. But they need to assemble themselves into more complex structures to be able to self-replicate, change, and evolve. This would happen in the second step, where we start to see the formation of microscopic organisms. In the third step, these cells combine to become multicellular beings, allowing for more complexity and variety. The step above sees species that can evolve big brains, enabling the use of tools, culture, and shared knowledge. That's where humanity is located. Looking at this ladder, one might ask, so what does it take for a multicellular organism to evolve into fully formed humans? This is what is called the Great Filter. It's a huge evolutionary jump that takes a lot of effort and the perfect environmental conditions for it to happen. And given that we haven't heard of any other extraterrestrial civilizations out there, it might be that we're the only ones that were able to make this jump. After all, how likely is it that we'll find life outside of Earth that is similar to us? That depends on how many planets there are out there in their star's Goldilocks zone, the area around a star where water can be liquid. And because stars come in all sizes and configurations, this zone is different for every star system. But that's not the only criteria we know for the existence of life. We usually look for three things to detect life: liquid water, methane, and oxygen. Water is what allows for chemical components to mingle and connect, forming multicellular beings. Methane is produced by the decomposition process made by bacteria, and oxygen is the byproduct of plant respiration. These are some of the telltale signs that the James Webb Telescope was programmed to search for. The James Webb Telescope has ambitious purposes that might revolutionize space science. Its top priorities are to detect forms of life by studying small galaxies orbiting the Milky Way. It will also look for the oldest stars in the universe, trying to gather data on the origin of the universe itself. That's huge! NASA is betting on two variables with this new telescope: a thorough scan on the so-called exoplanets, aka planets from outside our solar system, and the search for extremophiles, a type of life that loves extreme environments. Extremophiles were first discovered on planet Earth back in the 1960s at the bottom of the sea near the Galapagos Islands. Scientists found microorganisms living next to hydrothermal vents that dot the sea floor over that part of the world. Thriving in places like these with extreme temperatures over 700 degrees Fahrenheit takes a lot of resistance. I mean, can you imagine the heat? This discovery was a turning point for the field of astrobiology, as scientists understood that life could survive in extremely harsh conditions, similar to the atmosphere available in several exoplanets. But hey, life might turn up in our own neighborhood if we're lucky enough. Guided by the mantra, "Follow the water," NASA is launching two important missions inside our solar system that can contribute largely to the search for extraterrestrial life. You remember Jupiter, right? It's the gas giant that has a moon known as Europa. A few years ago, scientists discovered that Europa had an ocean hidden behind layers of icy crust. And there's even more. According to research, the water over in Europa is salty, much like the water we have on our planet. Europa is a big contender for the detection of life. But the Europa Clipper mission is not aimed at trying to identify this. Rather, it will orbit the moon and gather as much information about its atmospheric conditions as it can. The other moonbound mission is the Dragonfly, an octocopter that will explore Saturn's moon Titan. The launch is programmed for 2027 and will only arrive in Titan's orbit around 2034. It will sample and examine a series of promising sites around Saturn's icy moon. And who knows, find some new information on ET life? Let's see what happens. But I'd say we've never been closer to a huge discovery than we are now.
I bet you're dreaming of traveling deep into space, but I'm just as sure you don't know even half of all those amazing things that are happening in our home solar system. Like ice-spewing volcanoes on Pluto, a potential giant planet lurking on the outskirts of our solar system beyond Neptune, or a giant canyon the size of the United States on Mars. Let's have a look. First of all, let's travel closer to our Sun and see how insanely massive it is. Want some proof? Well, 99.86% of all the mass of the solar system is the mass of the Sun. In particular, hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. I live on one of those. Oh, and even though you might not have noticed it, we live inside the Sun. Wait, I didn't mean we're the inhabitants of the red-hot ball of light approximately 93 million miles away. No. The fact is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar winds from the Sun which create such breathtaking phenomenon as the northern and southern lights. Oh, and while speaking of the solar system, you must know that it's a whopping 4.6 billion years old. Scientists came to this conclusion after they studied the oldest material they could get. I mean, meteorites, of course. The solar system is also breathtakingly vast. You'd have to travel 11 billion miles away from Earth before leaving it. Wow, just think of the frequent flyer miles you'd get. Uranus rotates on its side, and astronomers have no idea how the planet chose such an unusual position. The culprits could be ancient mega-powerful collisions, but so far, it's just a theory. By the way, Uranus is the only planet sitting on its side. Its equator is nearly at a right angle to its orbit. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait, it's not the ocean you think about. The one on Jupiter isn't made of water. It contains metallic hydrogen, and its depth is a staggering 25,000 miles. This is actually almost the same as the circumference of Earth. Volcanoes on Earth are different from those on Pluto, like fire and ice. And I mean it literally. While we have scorching hot lava spilling volcanoes on our planet, volcanoes on Pluto spit ice. When frozen, water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano is formed. By the way, as you may remember, Pluto used to be a planet, but this title was taken away in 2006 by some astronomical bureaucrats. Later, Pluto was reclassified as a dwarf planet. But the most unexpected fact about this space body is that its diameter is smaller than that of the U.S. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,700 miles. As for Pluto, it's only 1,470 miles across. Now, even if you're a tiny celestial body, you can still have a moon of your own. In 1993, the Galileo probe was traveling past a miniature asteroid that was no more than 20 miles across. Imagine astronomers' surprise when it discovered that the little thing had a 1-mile-wide moon. Since then, scientists have found tons of moons orbiting minor planets of our solar system. Jupiter's moon, Io, exists in eternal chaos due to hundreds of smoking volcanoes on its surface. If you decided to visit this place, you'd see the smoke from these volcanoes billowing up high into Io's atmosphere. At any given moment, here on Earth, you can stumble across a rock that once came from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places all over our planet, they came to the shocking conclusion that lots of those have a Martian origin. In many sci-fi movies about space, the main character accidentally gets into an asteroid belt and has to try hard to get away from countless rocks that threaten to damage their spacecraft. Well, it's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is almost zero. Now, beyond the orbit of Neptune, there's a mysterious Kuiper belt filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Unlike what most people believe, there's water all over the solar system, and someone should wipe it up, huh? For starters, it's a pretty common component of comets and asteroids. You can find water in the shallowed craters of the Moon and Mercury. Mars has some ice at its poles, too. The same goes for smaller members of the solar system, like dwarf planet Ceres or Saturn's moon Enceladus. Astronomers even suspect that Jupiter's moon Europa might have some life. Under its frozen and cracked surface, there's likely to be liquid water. Europa is smaller than Earth, but it may host a giant and deep ocean that could contain twice as much water as all the oceans on our planet combined. Now, you might know that Mercury is the smallest planet in our solar system. It's also very dense, the second densest after Earth. But this mini-planet is getting even smaller and denser. After the Messenger spacecraft did its first orbital mission at Mars and mapped the entire planet, astronomers found out that Mercury is very likely to be a tectonically active planet. On its surface, there are cliff-like landforms, also known as fault scarps. They're quite small, which makes scientists think that they appeared not so long ago. In other words, the planet might still be contracting. Now, look at these magnificent rings. You can say without any doubt that this planet is Saturn. People have known about its rings since the 1600s when the first telescopes were invented. But Saturn isn't that unique. Nowadays, we know that every planet in the outer solar system, Neptune, Uranus, Saturn, and Jupiter, has a system of rings. And since we've started talking about the planets of the outer solar system, let's have a look at Neptune. This ice giant is around 30 times as far from the Sun as our home planet, which means it gets less light and heat from our star. But the planet radiates a lot more heat than it's taking. If we compare Neptune to nearby Uranus, we'll see that even though Uranus is closer to the Sun, it emits almost the same amount of heat as Neptune. Astronomers haven't figured out why it happens yet. One of the most unusual moons in the outer solar system is Uranus's moon Miranda. It has craters, sharp ridges, and other bizarre disruptions on its surface. Such phenomena are usually the result of volcanic activity. But Miranda is way too small to generate such a large amount of heat on its own. Astronomers think that it might be the gravitational pull from Uranus that heats and contorts Miranda's surface. But so far, it's just a theory. And there's no truth to the story that Miranda has a brother moon, Lin-Manuel. Finally, our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses over 100 billion solar systems. And if it's just our galaxy alone, what can we say about the whole universe? Solar eclipses are cosmic magic tricks during which the moon suddenly swallows the sun. Only they work not on magic, but on simple science. Let's try to find out how exactly they work and how you personally can observe this fascinating event. It all starts when the moon, the sun, and the earth line up in a straight line, with the moon positioned directly between us and our favorite star. This alignment is possible because the moon's orbit around the sun is slightly tilted relative to the Earth's orbit around the sun. Solar eclipses only happen during new moons, when the moon is closest to the Earth in its orbit. So, when the alignment is just right, the moon's shadow is cast on the Earth, blocking the sunlight from reaching us. Imagine being in a room with a giant light switch, but instead of turning the light off, you just cover it with a big old moon. It's basically the solar eclipse. Solar eclipses aren't a regular occurrence, and they only happen a few times each year. The frequency of solar eclipses is determined by many things, like the alignment of the moon, sun, and earth, and by the position of the moon in its orbit around the earth. Now, there are three main types of solar eclipses: total, partial, and annular. A total solar eclipse occurs when the moon completely covers the sun's disk, and the sky becomes dark as if it were nighttime. This phase can last for a few minutes to just over an hour, depending on the distance between the moon and the earth at the time of the eclipse. A total solar eclipse can only be visible from a specific region on the earth called the path of totality. This path is typically a narrow strip of land or sea, and if you happen to be exactly in the right spot, you'll be able to enjoy this wonderful view. Unfortunately, not everyone is so lucky to get to see a total solar eclipse. Sometimes the moon only covers part of the sun. In that case, you'll see a crescent-shaped sun instead of a completely swallowed one. That's called a partial solar eclipse. And if you're really unlucky, the moon might be too far away from the Earth to completely cover the sun. In that case, you'll see a bright ring of sunlight around the moon's silhouette. That's called an annular solar eclipse. Solar eclipses are some of the most spectacular celestial events that we can observe from Earth. People have observed and studied them throughout history, and they've played a significant role in our understanding of the sun, moon, and Earth. For example, we use them to measure the size and distance of the moon and the sun, to study the solar atmosphere, and to test Einstein's theory of general relativity. Solar eclipses have always been important to people, so it's not surprising that they've always been connected to different myths and superstitions. Some cultures saw them as a sign of dreadful things to come, or a way to talk to their deities. Others thought they could be used to predict the future or scare away evil spirits. All these beliefs show how much solar eclipses have meant to people. There have been many fascinating and memorable solar eclipses throughout history, each with its own unique story or significance. Here are a few examples of some of the most mysterious, cool, or just famous solar eclipses. The eclipse of Thales is one of the most famous solar eclipses in history. It's said to have occurred in the year 585 BCE, and it was reportedly predicted by the ancient Greek philosopher Thales of Miletus. According to legend, Thales was able to predict the eclipse by observing the cycles of the moon, and his prediction is said to have amazed and frightened the people of the time. The eclipse of Ptolemy was a total solar eclipse that's said to have occurred in the year 150 CE. is famous because it's mentioned in the writings of the ancient Greek astronomer Ptolemy. He used his observations of the moon's cycles to make his prediction, which astonished and alarmed people of that time. The eclipse of the century was a total solar eclipse that occurred on July 11, 1991. It was visible across a substantial portion of South America. It was the longest total solar eclipse of the 20th century, lasting for more than 6.5 minutes. The eclipse of the pyramids was a total solar eclipse that occurred on March 20, 2015, and it was visible from parts of Europe, Africa, and the Middle East. It got famous because it passed directly over the ancient pyramids of Giza in Egypt, providing a unique opportunity for scientists and tourists to study the eclipse from this historic location. And, of course, the Great American Eclipse of 2017. It was a total solar eclipse that was visible across a large portion of the United States from coast to coast. It was the first total eclipse visible from the contiguous U.S. in nearly 40 years, and it attracted millions of spectators and was widely covered by the media. Since they happen quite rarely, you wouldn't want to miss such an event. Fortunately, we have a calendar of solar eclipses that will occur in the next few years. The Great North American Eclipse of 2023, expected to be visible in a substantial portion of North America from the Pacific Northwest to the Great Lakes region. It will be the first total eclipse visible from the United States since the Great American Eclipse of 2017. The Eclipse of the Andes of 2024. This one is expected to be visible across parts of South America, including parts of Chile and Argentina. It will be the first total eclipse visible from South America since the eclipse of the century in 1991. The eclipse of the Arctic in 2025. This one will be visible in the Arctic part of our planet, including parts of Canada and Greenland. It will be the first total eclipse visible from the Arctic in nearly 100 years. And the eclipse of the Pacific in 2026. This eclipse will be visible across parts of the Pacific Ocean, including parts of Australia, New Zealand, and the United States. It's worth noting that the exact timing and visibility of these solar eclipses may change as more precise predictions are made. Also, some other solar eclipses may also occur in the coming years. Don't forget to check the details online. But the most important question is, how do we watch them? The answer? Very carefully. Here's some general tips. Use proper eye protection. Never look directly at the sun, even during an eclipse. It's not worth risking your sight. To observe a solar eclipse safely, use things like certified solar eclipse glasses or a pinhole projector. These devices allow you to view the eclipse without looking directly at the sun, and they help protect your eyes from the harmful effects of the sun's rays. Find a good viewing location. To get the best view of a solar eclipse, it's important to find a location that is within the path of the eclipse and has a clear view of the sky. Use a camera or telescope. If you have a camera or telescope with a solar filter, you can use it to take pictures or observe the eclipse more closely. Just be sure to use a solar filter to protect your eyes and equipment. Stay informed. It's important to be up to date about the details of a solar eclipse, including the exact timing, location, and type of eclipse. This information can help you plan your viewing and ensure that you have the proper equipment and safety precautions in place. That's it. Simple, isn't it? By following these tips, you can enjoy observing solar eclipses safely and responsibly. And if you do get to see a solar eclipse, make sure to snap some pics and share them with your friends. Remember, it's a once-in-a-lifetime experience after all.
For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP890-9b and LP890-9c. Buckle up because we're heading to LP890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but is packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Scariest telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP890-9b. It takes about 3 days to complete 1 lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP890-9c. This one was discovered by the Scariest telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now, this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias, has found 2 Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these 2 planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet, just like Earth. And if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP 890-9c. That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great! Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited.
Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies. 2 of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yep. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name – blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light. But we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our Sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time, due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that Interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-grandchildren will be around to see.
It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
The soil beneath your feet is red and dry. The place is freezing cold. Rusty-colored dust is floating in the air. You make one step, then another. It's hard to move because of the thick layer of dust your feet are sinking into. You're on Mars, and you've come here after hearing some absolutely incredible news. These days, the so-called red planet indeed looks dry and dusty. But scientists think that this world might have been very different a long, long time ago. They have found some evidence of a huge ocean that could have existed on the surface of Mars about 3.5 billion years ago. And this ocean probably covered hundreds of thousands of square miles. It all started with numerous satellite images of the surface of the red planet. They were snapped at different angles. As a result, researchers managed to construct a relief map of the area. They charted out more than 4,000 miles of specific formations that had most likely been carved by rivers. Those formations could also be channels, once carved out on the sea floor. Scientists used the data gathered by the Mars Reconnaissance Orbiter in 2007. They analyzed the thickness of the ridges and their angles and locations. Their main goal was to explore the topographical depression called Aeolis Dorsa. It turned out that all those years ago, this part of the red planet had been undergoing a series of constant changes. They could have been caused by the rapid movement of rocks, pulled around by currents and rivers, as well as noticeable increases in sea level. Researchers also noticed a pretty clear boundary that separated the southern highlands of Mars, elevated and highly cratered, from the smooth lowlands of the planet. It looked very similar to a shoreline left by a ginormous ocean. This all likely means that in ancient times, there indeed was an ocean on the surface of Mars, and a large one at that. What's even more exciting is that the existence of such an ocean might mean the existence of life. This discovery can tell scientists a lot about the ancient climate on the red planet, as well as its evolution. We now know there had to be a period on Mars when the planet was quite warm, and its atmosphere was thick enough to keep so much liquid water. What's even more incredible, the climate in the northern hemisphere of Mars 3 billion years ago could have resembled the one we have on Earth nowadays. But then, where is this ocean now? What happened to it? Perhaps the climate of the red planet was becoming cooler, and the surface of the ocean froze. There's a theory claiming that these days, the ocean remains in its frozen state, deep under a layer of rock, debris, and dust under a northern plain called Vasticus Borealis. Or the ocean's waters could have been lost to the atmosphere, and eventually space through the process of atmospheric sputtering. During this process, atoms get knocked away from the atmosphere after colliding with high-energy particles coming from the sun. Anyway, the theory of an ocean that once covered a substantial part of Mars's northern hemisphere hasn't been confirmed yet. Scientists are still arguing about its existence. As for now, Mars is a very cold world with an average temperature of negative 80 degrees Fahrenheit. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. The ocean that might have existed on Mars isn't the only awesome thing about this planet. Let's speak about those sandstorms raging on the red planet. In movies, they're depicted as incredibly powerful forces of nature, destroying astronauts' camps and tearing their spaceships into pieces. But how much of it is true? Mars is indeed infamous for producing dust storms so massive they can be seen by telescopes on Earth. They sometimes cover continent-sized areas and can last for weeks at a time. But besides them, there are much rarer storms that occur once in 3 Mars years, which is about 5.5 Earth years. Such storms are larger and much more intense than regular ones. They encircle the entire planet. That's why scientists call them global dust storms. At the same time, it's unlikely that even a global dust storm could cause serious harm to astronauts or their equipment. Even though Martian storms are massive, the wind speed reaches 60 miles per hour tops. That's less than half the speed of most hurricane-force winds on Earth. Plus, this comparison of wind speeds can be kind of misleading. The atmosphere on Mars is just 1% or so as dense as the atmosphere on our planet. It means that the wind there needs to blow much faster to cause any damage, or even fly a kite. Now let's move to the next amazing phenomenon spotted on the red planet. When you look at it from a distance, it looks like an eye. There are even some winding channels that look like veins running through the eyeball. But the closer you get, the less the formation looks like an actual eye. It's actually a giant crater, almost 19 miles in diameter. Around the crater, which looks as if it has a pupil, there are other, even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once, water filled the ginormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Your next destination is Valles Marineris. That's an enormous canyon, or rather, a canyon system that runs along Mars's equator. It stretches for more than 2,500 miles. It's also 4 times as deep as the famous Grand Canyon on Earth. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Most scientists think that Valles Marineris is a huge tectonic crack in the crust of the red planet. It could have formed when the planet was cooling down in the distant past. Another breathtaking sight on Mars is the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which means it's almost the same size as the state of Arizona. The mountain is also 16 miles high and rimmed by incredibly tall cliffs. To imagine the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, around 2.6 miles high and 75 miles across, which actually sounds pretty impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. Scientists have been wondering for quite some time why this volcano is so large. It might be the result of lower surface gravity and higher eruption rates. Or the reason may be the red planet's crust, which is very different from Earth's. On our planet, the crust is made up of 15 to 20 moving tectonic plates. As plates move over hotspots that produce lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. Now, if you visited Mars and decided to go on an evening stroll, you'd witness a strange phenomenon. It occurs on the red planet after sunset, when temperatures fall below -80 degrees Fahrenheit. A bizarre, mysterious glow spreads across the Martian sky. Unfortunately, without special equipment, you wouldn't be able to observe this soft glow. Visible only in ultraviolet light, this night glow is the result of chemical reactions that occur dozens of miles above the surface of the red planet.
Here on our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in our cells. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Well, let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the United States in size. And all this amount of water would only be 0.02% of the total mass of Earth. So, it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then, we'd get a very creepy ocean planet. The planet would look like one boundless ocean. It'd be very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins, all because the humidity would be that high. But could there still be life? Well, maybe inside the ocean itself? Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice. But not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice 5, Ice 6, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at high temperatures. And there would be almost no algae or anything like that. So fish would simply have nothing to eat. That's why, if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes, but it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of the Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71 to 50%. In this case, the sea level would drop by about 2 miles, and a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. At first, it would seem pretty cool. Now, you could literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat. But in places where there used to be deep oceans, you would see vast corridors and steep crevices. Now, here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them. But there would still be a lot of other cool places. For example, the ancient Roman city of Baia, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air, and since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? Now, to make matters worse, there would be nothing to extinguish these fires, because, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable, not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So, all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans, most likely, would make a big evolutionary step backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all of our might.
These days, you're better off boarding a plane if you want to travel from New York to London. But what if I told you there was a time when these two cities were actually on the same continent? Well, the explanation is a bit more complex. For starters, back then, these two cities didn't even exist at all. But the tectonic plates they sit on today were a lot closer. Nearly 200 million years ago, all of the continents on our planet connected, making up one large supercontinent. This enormous piece of land was surrounded by one single ocean. We call this huge continent Pangaea these days. Some parts of this continent broke apart and shifted away from each other for our maps to reach their current configuration. There's even a nice experiment you can conduct to test this theory. Find a map online and print it on a piece of paper. After that, simply cut out all of the continents. Once you start playing around with them, you'll soon notice they all seem to fit together, like pieces from a puzzle. Probably the most striking thing you'll see is how South America perfectly fits Africa. What's even more fascinating is that this isn't the first time in our planet's history that supercontinents have been formed and then broken apart. Scientists have figured out that this happened at least 3 times before. And if we consider our planet's age, 4.5 billion years, the last 200 million is closer to the blink of an eye. So, how did scientists figure out that continents move? Apart from the aspect of today's continents, they also looked at identical rocks, which have been found on different continents. They looked like they formed from the same minerals and under the same weather conditions. Some other secret helpers? Well, dinosaurs. Fossils from the same species have been stumbled upon in both South America and Africa. This particular dinosaur, named Mesosaurus, is said to have lived on our planet way before the continents drifted apart. It's hard to imagine how life on Earth must have been with one single continent. For starters, the climate must have been very different. That's because the mid-portion of the land would have probably been bone dry, having little to no source of water. More so, it was most likely hidden away behind many mountain chains. These would have acted as a barrier against moisture and rainfall too. However, geologists have also studied coal deposits from the United States and Europe. These seem to show that at least a part of the ancient supercontinent, which was close to the equator, must have been an amazing tropical rainforest, just like those we can find in the Amazonian jungle today. Coal appears when remnants of plants and animals get stuck into swampy water. If enough pressure is applied by the water, the substance is first turned into peat, then into coal. Our planet existed in this continental configuration for over 100 million years, and during this time, there was a lot of life on Earth already thriving. Hey, it was a great time to be an insect. Critters like beetles and dragonflies flourished. During the same time period, the Earth was roamed by the predecessor of all mammals, the synapsid. Life in Pangaea was severely hit during one not-so-great period. It's believed that a comet or asteroid landed on the surface of the Earth about 251 million years ago. The asteroid or comet theory seems to fit pretty well because 90% of all marine animals and 70% of the creatures living on land disappeared all of a sudden. The comet might not have been the only reason for the mass extinction. At the same time, there was also some important volcanic activity happening in northern Asia, which might have disrupted life on Earth. We may not notice it, but continents do continue moving as we speak. This configuration we now see with the help of satellite imagery will surely not be the last. Australia, for example, is slowly moving towards Asia. But the most important proof that our continents are still shifting is the eastern portion of Africa. This area is simply breaking off from the rest of the land. To witness this, you'll have to travel to one of the hottest places on our planet. But if you get to this piece of land on the eastern part of the African continent, you might sit on top of the exact spot that, soon enough, will be split in two by water. Underneath this region, 3 tectonic plates are slowly drifting apart. If the data is correct, in the far future, Africa will be split in 2, and between its 2 regions, a new ocean will arise. To support this theory, scientists have been closely studying a 35-mile-long crack in the Ethiopian desert for years. For this new ocean to form, it's estimated that 5 to 10 million years need to pass. Since our planet's crust is made out of multiple tectonic plates that are constantly moving, it's the perfect place to study this process. These plates are all irregularly shaped, and they are always mashing against, sliding under, or over each other. Those 3 tectonic plates found under the desert are also moving at different speeds. One of them, called the Arabian Plate, is sliding away from Africa at a speed of about 1 inch per year. The other 2 plates are moving a bit slower, somewhere between half an inch to 0.2 inches each year. More so, as these movements happen, material from deep inside Earth climbs to the surface and forms an oceanic crust at the edges. All this movement does make you wonder, how will the next supercontinent form, and when? So far, scientists came up with some possible configurations, each with its own name: Novo Pangea, Pangea Ultima, or Amasia. All these predictions still vary, as we're not sure how and why continents really move over time. One clue may be actually looking at how Pangea separated in the first place. Regardless, it will take anywhere from 15 to 100 million years to see the next future continent, depending on each scenario. Novo Pangea looks at the possibility in which present-day movements continue. In this scenario, the Atlantic Ocean will continue to expand, all the while making the Pacific smaller. The 2 American continents would first combine northward. Africa, Europe, and Asia will have already combined too, by the time they all meet together in one single huge piece of land. Another possible scenario is called Pangea Ultima. In this case, the Atlantic will slow down in its expansion and actually become a landlocked body of water. North America, Africa, Asia, and Europe would become somewhat parallel pieces of land, completely sewn together. Underneath them, South America, Antarctica, and Australia would complete the circle surrounding the North Atlantic. All the while, this piece of land would be surrounded by a large Pacific Ocean. Amasia looks at a scenario that's a bit difficult to understand and study at this point. Since several tectonic plates look like they are moving north, it might be possible that all continents, apart from Antarctica, will slide completely toward the North Pole. The climate would be a lot different and way colder. Both the Pacific and the Atlantic, in this scenario, would remain open bodies of water. Scientists believe this to be a real possibility because of some anomalies left by Pangea deep in the Earth's interior in the part called the mantle. Looking even further into our planet's future, it's estimated that in about 1 billion years, the luminosity of the sun will be somewhere around 10% higher. As such, the atmosphere on Earth will closely resemble that of a moist greenhouse. Because of the added heat, all the bodies of water on our planet will start to rapidly evaporate. Moving further to 4 billion years from now, the temperature on our planet will soon transform it into a Venus look-alike. It might get so hot that the Earth's surface will begin to melt away.
Ever wondered what it would be like to hear the sound of a black hole? NASA's got you covered. Here is a screaming black hole. Screaming in space? I thought in space no one can hear you scream. Well, let me explain. Using a telescope, NASA examined the movements of hot gas in a cluster of galaxies in 2002. Then they converted what they found into a sonification. The sound, how can I put it politely, wasn't appealing, but that's okay. After all, you're able to hear the noise hot gas produces in a cluster of galaxies 250 million light-years away. Hey, how would you like to hear the sound gas produces right here on Earth? Never mind. Sound waves already existed over there in the gas cluster, so experts just rescaled them to the range of human hearing. This is how they converted the input coming from the telescope. The principle is universal. In our atmosphere, we can hear stuff because pressure waves move through a medium like liquid or gas. Sound waves in these galaxies can also move because they're surrounded by gas. What does it have to do with black holes? Well, the thing triggering those pressure waves in the cluster is a giant black hole. To be more precise, it's a supermassive black hole that weighs millions of times more than the Sun. Wow. Experts still don't fully understand the relationship between supermassive black holes and the clusters surrounding them. They only know that these two evolve together. They're interrelated. The cluster feeds the black hole with new material and so on. And in return, the black hole heats the cluster. That's all we know. Now, this made me wonder how large the biggest black holes are. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. Naturally, the biggest ones fall into the category of supermassive. The largest black hole in the universe we've discovered so far is about 66 billion times larger than the Sun. It's one of the brightest objects in the universe. Astronomers keep scanning space and finding new black holes. But have you wondered when the first black hole was spotted? It was discovered by different researchers independently in 1971. Scientists first confirmed that these objects were formed from the remnants of massive stars. After a black hole appeared, it then consumed all the nearby objects. Here is a quick recap of how these space objects work. Their gravitational force is super strong. Nothing can escape a black hole after crossing the event horizon. Black holes eat everything, just like me. I mean, even light gets trapped inside them. What's even cooler/scarier is that the laws of time and space become distorted there. If you were falling into a black hole, you would realize that time slows down there. Einstein explains this in his famous general relativity theory. In very, very basic terms, time gets affected by how fast you are moving at extreme speeds. NASA has discovered a rapidly growing black hole, but don't worry, the world isn't in danger. This black hole has been in front of the eyes of astronomers this whole time. It's in a region of a well-studied sky field. Astronomers say that this hole formed 750 million years after the Big Bang, the birth of our universe. So why are black holes so bright? Well, that's a bit ironic. When I defined this space phenomenon, I said that black holes were so dense that even light got trapped there. But ask any astrophysicist, and they'll confirm that black holes are among the brightest objects in space. That's because black holes don't exist alone. They sit at the centers of galaxies and are usually surrounded by clouds of hot gas. And these clouds create cosmic auroras around black holes. I must mention, though, that you can't see a black hole directly. What you see is actually the effects it has on its environment. For instance, you can see space objects being ripped apart by a black hole. Remember when the first time ever silhouette image of a black hole was shared with the public in 2019? Proof, you fellas. You wouldn't really see the black hole if there was no orange ring. Why is the ring orange and not green or purple? The dark shadow inside is the shadow of the black hole. The glowing orange of the bright ring in the image isn't the real hue of the gas. I'm a little heartbroken here. It's a representation picked by researchers to depict the brightness of the emissions. A scientist explained that yellow is the most intense emission, red is less intense, and black has little or no emission at all. In the optical range, this ring would likely seem white, perhaps tinged with blue or red. Now, spaghettification is a real word. That's an astonishing ability black holes have. If a giraffe fell into a black hole, it would stretch into a long spaghetti-like strand. On Earth, the giraffe's legs are closer to the center of Earth, so they're more powerfully attracted to the surface than the animal's head. This rule works in the animal's favor on Earth, but would work against it inside a black hole. In a black hole, there's extreme gravity. The closer the giraffe's legs got to the center of the black hole, the more the pull of gravity would stretch them. And the closer to the center the giraffe got, the faster its legs would move. But the top half of the giraffe's body would be farther away, so it wouldn't move toward the center as fast as the legs. Here comes the spaghettification. Can we have meatballs with that? No? Okay. The only difference between a black hole and our sun is that the center of the hole is made of super dense material. It provides the black hole with a strong gravitational field that can trap everything, including light. This is why we can't see black holes. Did you know that, theoretically, you could turn anything into a black hole? For instance, if you shrank the sun to approximately 4 miles across, you would compress the matter inside to an extremely small size. This would make it so dense that our star would turn into a black hole. You could do the same with a planet or even your own body. Is there something called a white hole, or is it just a myth? White holes exist in theory. Hypothetically, they function in the opposite way to black holes. Nothing can enter them. Physicists think of black and white holes as yin and yang, or two sides of the same coin. For them, a white hole looks exactly like a black hole, which makes different things come out of it. But the existence of white holes hasn't been proven yet. And how about wormholes? There are so many movies about black holes and wormholes. How many of them are based on reality, and how much is fiction? Some people believe that black holes function like wormholes. You go inside and exit in another part of the universe. Since we still have a lot to learn and discover about physics, no one can prove this theory is wrong or right. Astrophysics says we need to have a solid theory that unifies general relativity with quantum mechanics. Black holes are among the largest structures in the universe, but there might be tiny specimens. The mass of the smallest black hole we know about is only 3 times greater than that of our Sun. Now, apparently, black holes can vanish. Stephen Hawking developed a theory of Hawking radiation. According to it, radiation decreases the mass and rotational energy of black holes, and ultimately they evaporate. This process occurs very slowly, though, if we're not talking about small black holes. Astronomers have discovered an elusive black hole in the neighboring galaxy. What makes this one special is the fact that it's the first dormant stellar black hole outside of our galaxy. This type of black hole is hard to observe because such holes don't interact much with their environment. They don't emit as much radiation as other black holes. Well, back on Earth, what about sinkholes? Well, different physics. Yet, if you cross the event horizon, your whole car can disappear. Whoops!